Okay, we're going to do a little retro radio video today. This is an old Eico, not ICOM, Eico, E-I-C-O, vintage radio, model 753. I bought in 1977. It was my first radio. Bought it for 60 bucks out of the want-ads. I'm not going to go through a whole discussion of the circuitry here, just a few key points. For those of you that are young enough that you've never seen these type of things, I'll take the covers off. These are as shields, as RF shields. I can't pull that one off. I'm not going to strain it. It looks just like that. And then we have these two down here. Okay. So I'm just going to show you what these tubes do. These tubes have actually been replaced by semiconductors, such as MOSFETs and other transistors. So we'll start over with this one. This one is the mic gain amplifier. It does 2 stages of amplifying for the microphone input. Regulator. It glows purple because there's a gas in there to make it act like a regulator. I don't know what the gas is. It's either xenon or I can't remember the name of the other one, neon. I don't think it's neon. I think it's xenon, but I'm not sure. This one, this is our crystal. This is for the crystal controlled oscillator. This one is. This one is a balanced modulator. This is the balanced modulator for voice through the microphone, and this one is a Vox amplifier for the voice operated transmit. This one over here is an audio amplifier to the speaker, and this one is the driver for that one. It's a preamp to amplify that to go out either your headphones in the back. This has a cord that goes to an output here and plugs into the power supply. I think it's off your screen, but there's a power supply over there that has a speaker in it. This is a receiver input amplifier. These are all IF amplifiers. All of these in here for the IF stage. This is a transmitter mixer tube and also for CW key. This one here is your preamp to the finals. Your final amplifiers are these two big giant things. We'll get to how I burn those out twice. It's easy to do. So we're going to move the camera to a face onto the front of this and show you. The reason I wanted to do this video was to show, especially the younger crowd, what we had to work with not even in the beginning. This was 1977. That's not that long ago. I was in my teens then. So we're going to move this camera and show you what you had to go through just to set up to transmit. Now here, just show you some stuff I have on the table here. This is a power supply. Don't worry about it. It's not for this radio. It is just to supply 12 volts to the watt meter, which is semi-functional. It's got intermittent problems. I hope it doesn't act up, but it doesn't matter if it does. We'll ignore it. And over here, this big black box here, is the actual power supply that came with this. This little can of paint is actually a can of oil and resistors for a dummy load. I'm not going to transmit out on the air when I do this demonstration. This light is here for fun. Now we'll move our camera. And yes, this is the same radio that looked like it blew up on all my introductories of these films, and no, I didn't blow it up. But it was fun doing what I did, but I didn't really blow it up. Someday I probably will by accident. Some people would refer to this as a boat anchor. No ham radio is a boat anchor. If they don't work or they're too old to be used, they're not boat anchors. They're either relics, fossils, or parts. So I'm going to turn on this back power supply just to light up this so it's easier to read when I don't even know if it made a difference. And now we're going to turn this radio on. In the old days, there's a thing right here says standby. Let's see if I can zoom up on that standby and show you what we're standing by. Yeah, I think you can read that. It says standby. So what standby is, your tubes actually have a heating element in the cathode. And that heating element heats the tube cathode up hot enough so it will actually emit electrons as long as there's a vacuum inside that glass tube. If air leaks in, it won't work. It's like a light bulb. A light bulb has to be, the element has to be in a vacuum, otherwise it oxidizes and burns up. So there's actually a heating element in the cathode. The cathode emits whatever you're putting. It's like part of the input of the tube. So we have to let it warm up for 5 minutes. I'm not going to do that because I already did before I started filming. So we put this over to press to talk. Now, anytime, this is a tri-bander. I better get that unzoomed or you ain't going to see what I'm doing. Anytime you change the band, this is 3 bands, it's a tri-bander. It's also 3 modes. Anytime you change the band from one band to another, you have to go through a tune-up procedure. Modern radios don't do that. These did. If you didn't, you have to get all of your circuits, your amplifiers, your oscillators to be resonant, or it's not going to do anything but generate heat. So we put it in press to talk. We have a thing here says your mode switch. SSB, AM, CW, and tune. We're going to go to, and you have to do this quickly. If you don't, you'll burn up your finals. I did it twice. They have to be resonant. This, and this will make that happen. So we're going to go to tune. This is the exciter, also known as a driver. Okay, tune. I want to make this meter maxed. If this is working, which it is, hooray, put it on max. Turn it off, 5 seconds. You got 5 seconds to do that, or you start overheating those finals. Back when I burned them out, they were about $10 a piece. If I burn them out now, they're probably about $50 or $60 a piece. The price of the radio. So, let it cool down a little bit. We want to do the PA load. We want that. We'll go, yeah, let's see. Yeah, there we go. We want to peak the output. And that was more than 5 seconds. Don't you love the sound of that buzzing in the background? That's the power supply working to supply this thing with all that power. You've got some voltage back there, hundreds, 200, 300. Probably in those finals you could be up to 1,000 volts. Now we're going to do the tune, the plate tune. PA is plate. The plates are like collectors on the tube. You have the cathode, it shoots a beam of electrons to the plate. There's screen grids in the tube that introduce other input into there, whether you're oscillating or amplifying, whatever that tube, mixing. So we're going to turn that tune to maximum power here and shut it off. And then when you're all done, you're going to leave it on CW. You're going to move this to Vox. You move it to Vox. We're pretty much resonant now, so we don't have to worry too much about burning anything up. Once you get resonance tuned, get these circuits tuned with these controls, they get resonant, they start working properly, they don't generate as much heat. So now we're going to see if we can do our Morse code. And we're going to see if we can peak it a little more on that bottom meter, the watt meter. Let's go a little bit on the tune. This PA load. It looks like we get about 100 watts. This used to, he's old. He has not had any organs replaced. He could probably do better. He's supposed to be able to go up to 200 watts. We got about 100 watts out on CW, on 80 meters. Now let's say I tune it to 80 meters. I tune through here and I don't hear anything. It's like, man, 80 meters is dead. I want to go to 40 meters. Let's try 40 meters. You go to 40 meters, guess what? You have to retune all that and do everything I just did. Go, well, 40's no good. It's dead. Let's try 20. Again, you have to redo it. A matter of fact, it's so sensitive that if I stayed on 80 meters and I get down on the edge of the lower band on 80 meters, say down here in the CW range, and I tune it up, and then I see, I hear that, someone told me that there's a rare DX up on voice, up on the top of the 80 meter, 75 meter, and I go up there, guess what? I've changed it enough. I have to go through this and retune it again. You can retune it in the middle of the band, which is what I used to do. That way you may not have to tune it every time you switch from voice to CW to data to whatever. So that's what I wanted to do to just show some of the younger crowd what you had to do in the old radio days when you had these so-called boat anchors. Like I said, if they don't work and you can't get them to work, they're still not boat anchors, they're organ donors. Now, I'm going to shove this light bulb over. I don't believe you can do this with a solid state radio. I would not do it with a new radio. But I'm going to switch this antenna switch back here from my antenna I had over there, that dummy load, this one here. I'm going to switch it to our light bulb. It is just a lamp. And it's always fun to do this. The guy that sold me this did it the day he sold it to me, and I was a novice. I wasn't even licensed when I bought it. I was in the process of getting licensed. Yeah, let's make sure we're on 80 meters, and isn't that something? And we might be able to make it brighter too if I don't. Because I had changed this. I don't know what frequency I was on when I first tuned it, so we'll tune it again real quick. See, you can tell if you tuned up. Get it brightest you can. Shut that down. Wait a little bit. Let things cool off. I actually have what's called a muffin fan that this belongs in this case. I took it out of the case so I could show you its guts. And I have a little muffin fan I put on top over the circuits there, especially the finals, to cool it. So here we go. I'm trying to keep my arms out of the way. What did we do? Now I want to go to load. Oh yeah, let's get that baby loading. Oh, that's hard to look at. And let's get our PA tune. Oh yeah, we are on it. There you go. What do we got? 150, although our SWR blows. The thing about these, they don't have protection. It will let you run infinite SWR, and if you do that, you burn out the finals because they have to be resonant with the output of the radio. So you don't want to do this too long. But I just thought it was kind of cool to light up a light bulb with a radio. You'd really put it here on the dummy load, and then your SWR is 1-to-1. Of course, I'm not tuned very good over here because let's get that baby resonant. There we go, we're resonant now. We're not going to burn it up now. And the funny thing with the power supply buzzing like that, I never needed a side tone. I just listened to the buzz there, and you can send your code. And that's the story behind one of these. I have some other old radios that are similar to this that maybe I'll show those. And no, I don't have anything any newer than an Yaesu FT100D. But this was my first one. Oh, and another cool thing about these, they put off the heat from the tubes. They put off enough heat that they'll, if your ham radio room, your ham shack is not too huge, if it's like even the size of a normal bedroom, in the winter it will heat it up. I used to operate this out in a shed with no heat in December, and after a few QSOs, especially doing Morse code, because they take longer if you're at a slower speed, it would heat the shed up to fairly comfortable. It was jacket, but it wasn't, and I live where we get snow, and it was fairly comfortable, not toasty, but it would warm it. They'll warm up your room. I wanted to see if I could get that tube. Maybe I'll add that on later tonight when it's dark. I'll turn it on and get that tube, this little tube, where you can see it glowing. Get them all glowing. I think I have a still photo of it glowing. You can kind of see, let me get the reflection from the ceiling light off, but just under the ceiling lights you can see an orange glow. And I think I'll do that. I'll conclude this later with a light show besides the light bulb. Okay, one thing I got to say about using this light bulb, lighting up a light bulb with your radio. If it's something you want to show somebody else, if you think it's like really cool or whatever, that's okay. But it has to be, it must be a tungsten light bulb, a regular standard old-fashioned tungsten light bulb. You can't use an LED light bulb, I do not believe. You cannot use one of those mercury vapor bulbs, the curly ones, or anything like that, because those in the base of them have some kind of a ballast or transformer in them, and I have no idea what that would do to your radio or to the light bulb or anything else for that matter. The LEDs, I don't think it'll work with those. I think you're going to damage your radio. It has to be an incandescent tungsten element light bulb. Best if it's about 100 watts. The one I'm using here I think is somewhere around 50 watts, but 100 watts is better. I think it gives you better SWR for one thing. But do not use anything but a tungsten filament standard regular old-fashioned light bulb. So that's it. That's all. I hope you enjoyed it. Again, thank you for watching if you watched it this far. And like I say, if you like the video, like it. If you want to subscribe, subscribe. If you want to boo me off the internet, that works too.